So we can generate 3D solids by taking a function, so in this case this function f of x, that red line, and we can actually rotate it around the axes to create a three-dimensional solid. So this solid is kind of like a vase shaped on its side, and we can find out this volume of this solid by taking a look at each slice. Okay, so if I take each slice, every slice is going to be a circle. So if I slice it through like that, okay, so I don't know if you can see that, but slicing through like that, we're going to get the cross-sectional area is going to be the circle. So I can calculate volume by just basically using the principle that volume is area times thickness. So if I can find the area of each of these circles and multiply its thickness, I can find the volume of this slice. I can find the volume of another slice over here. I can stack all these volumes together, or in other words, integrate, okay, add up all these slices, and I'm going to end up with the volume of the whole object. Okay, so that's the idea around calculating these solids. Okay, we want to basically take this idea of area times thickness gives us the volume of this piece, and we're going to integrate or add up all those pieces to get the volume of the object. So first of all, it's good to kind of identify or recognize what these shapes look like. Okay, so visualize this shape. This line being rotated kind of gives you this vase shape on the side. So then to do it using these discs, in this case we're going to get circular discs. Okay, what we want to do then is to find out the volume. We're just going to take the volume of this one piece. Okay, we're going to take the area of this disc and multiply it by its thickness. Okay, so we've got the area of the disc times the thickness gives us this one piece here. Okay, so this is going to be calculated by pi r squared times the thickness. Well, the radius of that disk really is going to be this f of x. Okay, the height of this disk, or the radius of the disk, is the height of the graph. So that f of x then represents the radius for which we can calculate the area of that circle. So then when I do this, I want to sum up all those volume slices. So I take all those circles times dx, or delta x, and sum them up. And if I want to do this more precisely, I make my delta x go to 0, which essentially becomes dx. And summing it up means I'm integrating. So my integral looks like this to calculate the volume of that rotational object.